Hi, in this video we will be learning about the sequence structure. In case you want your program to flow in a way, in a certain sequence, then you can incorporate something called sequence structure. And the sequence structure looks like a frame of a film, and it executes diagrams sequentially. So in conventional text-based languages, the program statements execute in the order in which they appear. In data flow programming, a node executes when the data is available at all the node inputs, but sometimes it's necessary to execute one node before the other. Therefore, the sequence structure in LabVIEW's way of controlling the order in which the nodes execute. So you can see here the sequence structure. You can access it through the functions palette. You can go to the structures and select sequence. And then if you want to pass on values um, from one frame to the other frame, then you can use something called sequence locals. Just by right clicking on the frame and then selecting like add sequence local. So in this way, you can pass on the value, a certain data value from one frame to the next frame, but not to the frame that is preceding it. So yeah, this is the sequence local. So it appears in the next frame, but not in the frame before. It just appears something like this. Now I'm going to demonstrate the application of this sequence structure. I'm going to do the exercise 6.3, time to match VI. So here you will build a VI that computes the time it takes to generate a random number that matches a number you specify. This VI uses the Automatch VI you built in exercise 4.3. So did not um, I did not have the Automatch VI, so I'm just going to create it here. So drop a numeric control, number to match. Okay, then drop an numeric indicator here, current number. Then another indicator saying the number of iterations. And then another indicator says time to match. And we are going to put a free label here, seconds. Okay. Now let's go back to the code. Okay, before that we need to change this representation to an integer. Even this representation to an integer, and even this. Okay, let's go to the block diagram. So these are our outputs. Let's put them in a side. expand the window. So first we are going to generate a random number. For that, I have to go to numeric and select a random number generated, and then multiply this. We're just going to scale this value. Then I'm going to round this to the nearest value. And that would be my current, this will display the current number. This is my current number. And then we also have to compare the current number if these two are equal or not. So we are going to use a comparison not equal to. Yeah. So yeah, it's going to check if it is equal to or not. And we want this to run continuously. So let's drop a while loop. And this will keep running until a match is found. So if it is not equal, it will continue running. So that's why we can just change the loop condition here. Yeah. And then just move it here. So it will keep doing the loop again. And then we have to display the number of iterations. So for that, we know it starts with 0. So we have to increment this value. So numeric increment goes out. And here it goes. And we choose to set it to last value in the tunnel mode. Now, what should we do with the time to match? So we should have know what's the clock time. So we want to incorporate a sequence in this. So how do we do that? So first, we have to drop a sequence. Okay, I'm choosing a flat sequence here. Yeah, I first wanted to perform this operation. And then I want to right click and replace with stacked sequence. Okay, I want to have a stacked one. Or you can just undo replace. And then you can add frame after. So this is going to be my next frame. So first this operation is performed. So you have this option of tick to record the initial timing tick count. So it will record when the execution started. So we usually do not use flat sequence structure. So I would change it to okay, just gonna replace this with a stack sequence and then right click, add frame after. Okay. Then again, we are going to calculate the current time. So we go to duration, tick. What's the time here? And then we subtract these two values. And we want to display it in seconds. The value in this is in milliseconds by default. So we are going to divide this with 1000, create constant. It's going to be 1000. It here, and it should move it here. Connect this here. So we can, so I have to show you one more thing, that is how to set the data range. So you just need to right click on this, go to the properties, and then can go to data entry and uncheck use default limits. But before that, go to the display format and change it to scientific. And then data entry, the minimum based on the one shown in the PDF is 0.00. Okay, go to the properties. The maximum is going to be increment be 1. And change this option to coerce. goes to nearest. Then can we have the default value? Let's see how we can change the default value. Yeah, I don't see the option to show a default value, to change the default value. So for now it's fine. And this is how you change the range. So let's say if I have entered this value as 50. Okay, so it took so much time to generate the random value. Let's change the value to 25. Okay, its current number. It took so many iterations. It's super quick. If you want to introduce any kind of delay, then you can add any delay. And it took 0.01 second to generate it. Okay, so this is an application of the sequence structure. So it's first trying to run this portion, that is, it's continuously searching for it. So, and then if you want to see the rest of the portion, it's here. So the way this data flow happens is first it enters into the first data frame, and then this loop is continuously executed. And once the match is found, then it goes to the next one, and then it records the current time, and then the amount of time taken is calculated. So one way to see the data flow is like you can turn the highlight on and then just run it to see how data flows here. As you can see now, it's just looping here. It's not equal, so it's true, it's running. Yeah, it's going to take a lot of time, but you can run this code yourself and see how it executes this portion and then goes to the next part. So I'm just going to stop this for now, but you can try it by yourself.